Exeter University, and you'll be a little bit patient with us because we're moving between two different online and in-person presentations. So thank you in advance for your patience. So James, over to you.
Brilliant. Hello, hello. Hopefully you can hear me up in Loughborough and online. I'm deeply sorry there to start with. I got a bit of awful luck with trains yesterday. I was supposed to be there in person, but the trains didn't go very well. So hopefully you can see I've got a few slides prepared. I've got a bit of an awkward opinion, not opinion, but kind of viewpoint. I haven't really been taught using Lean, but I am an undergraduate that has taught using Lean. So nobody's taught me. I've been the one teaching. So, we can't really hear. James, can you hear me?
You're very quiet.
Yeah.
I'm very quiet. Oh, interesting. Yeah. But you can hear me.
I think it's
not there. It's full power here. Yeah.
I've been told you can hear me well online. I think my microphone is working, hopefully.
Sorry, we cannot hear you.
Apparently it's our fault.
You can sit closer to the
TV. Some full power in our end.
Let's see. Can I plug in this microphone? See if it is my microphone. If you can hear me.
Someone's on hand. They're going to fix it.
Oh, okay. Is it me or is it which side?
No, it's not you.
Okay. Well, we'll put the microphone in anyway. It's not your end. Okay, that's fine. I put my microphone in anyway, so just in case. Right, so that's fine.
James, can you try again?
Yep. Can you hear me now?
It's a bit better.
James, can you just shout really loudly?
I can shout a bit louder. Is this any better? Maybe deafening the people online, unfortunately.
Yeah.
Is this the speaker? Where's the speaker? Yeah, the speaker is.
James, try now.
Is this any better?
Oh.
I can see I've connected my proper microphone now, so it should.
No, it's not your problem.
It's our problem.
Oh! Oh no, I was excited for it.
Probably do.
Just sit here.
Fine.
I'll just turn the sound on when the laptop's on.
Yeah.
Ah, brilliant idea.
Yeah.
This is where I should have had a Mobius strip to hand to cut in half.
We've had a brilliant idea.
Oh.
This is great. Yeah. Just turn that one off.
It will be okay if we turn this one off. So,
Okay. Can you hear me now? I can't hear anybody.
Can you
James,
hear us,
James, can you try
I
now?
can hear you. Can you hear me?
Yeah, that's better. Yeah.
Brilliant. Can you see my slides?
Yeah.
Yes, we can. Thank you.
So you can see my slides, you can hear me. So I can get going. Okay?
Yes.
Brilliant. Okay, let's get going. Let's try again. Second try. Second time lucky. Okay, so as I quickly said before I got interrupted, I am a slightly interesting case. I have not been taught using Lean, but I have taught using Lean. So I've had students, not been a student. So you're going to have a slightly different perspective than anybody else who's going to speak this morning or this afternoon. I don't know. It's 12 o'clock. We haven't had lunch. So that's fine. Okay, so as a quick introduction, I'm James. You probably should know this by now. I'm a current student at the University of Exeter, and I'm studying mathematical sciences, and I'm a maths communicator down in Cornwall. So by day, I fiddle with geometric mechanics. I'm an applied mathematician, which is also potentially slightly different. And by night, I try to formalize it. So I've taught undergrads, postgrads, and PhD students. So I've got a bit of experience in teaching. So we're going to focus on three things: the good, the bad, and the ugly. So here's three things that I've really noticed while teaching that I thought were worth mentioning. So there's going to be good things, there's going to be bad things, and in the end, we're hopefully going to conclude to you saying, okay, I can either, this is a good thing for my class or not. I'm not going to tell you that. So firstly, the good. Tactics are an amazing thing, and I love them to bits. You'll see these in the practical sessions if you have not already, but in essence, they can solve trivial goals for you. These will help the students to be able to string things together and to create a proof. Because in essence, what we're trying to teach them in my Gihan's introduction to proof module is a proof is just a string of steps that we're going to put together, and Lean is a tool for using that. So at higher levels, these may obscure some kind of tricks or something more complicated, but for first years, these are very useful. We just want to teach them to string things together. The also good thing is instant feedback. Many courses I've had friends and I know students will complain that there isn't any solutions to exams or solutions to problem sheets. Well, Lean, they create the solution for you. Lean is the solution. If you've got a solution that works in your proof, then you're fine. So that's brilliant. It's great. And if students have fallacies in their proof, Lean will show it to them with a lovely red little squiggle. Okay, so the bad. So many first-year students struggle with learning proofs initially. It's something completely different to what they see at school. It kind of lays the foundation for many pure or even applied courses later in the degree. So it's the most important course, in my opinion, that you will take in your undergraduate or postgraduate, whatever degree, or even what class you're taking. So you have to be careful that you're teaching them maths, not Lean. Many of the students that I've taught think that maths is the same as Lean, which it'll come on to my big point in a minute. So the biggest problem also is that you may scare students. They see Lean and think, oh, Lean is hard, Lean is confusing, I don't know how to use computers, I can't do maths. And that is atrocious, it really is. We need to kind of enforce the idea that maths is not equal to Lean. They are two different things, and you can be good at maths and not good at Lean, and good at Lean and not good at maths. They're not isomorphic. They're not the same thing. So the ugly, this is kind of the thing that I most struggled with when I was first starting to do Lean is it's not user-friendly. It's really not user-friendly if you have not programmed before. So many of my students, they're kind of either they have a degree in mathematics or they don't have a degree in mathematics. And either way, that doesn't really imply that they have any sort of mathematical literacy, especially if you're a pure mathematician. If you're more applied, then maybe you've used Python or MATLAB to kind of run some simulations. But there's not a nice correspondence between mathematicians and people that can use computers. So you've got to be careful. A mathematician doesn't inherently know how to use the command line. So many students will quickly separate the idea of maths and computing into two different things. And we need to make sure that those stay a bit closer together. So there's ways around this, i.e. CoCalc, which you use at Exeter. But if you really want to get your hands dirty and want to do some sort of stuff with MathLib, you really do need a local installation. But we can deal with that. But this is the thing that you have to keep in mind when you're teaching your class. So quick conclusion, when tutoring, these students want to learn Lean. When my tutoring, my students really want to learn Lean. So they're interested and they want to get it to work. And so they're all really love Lean. But when teaching, that is usually not the issue. You'll get some students that love it, some students that don't. You'll get a mixed bag. And at the end of the day, you've got to make sure that you're teaching the maths and the students coming out of your class know how to prove things, And if that's through Lean, then brilliant. If that's not through Lean, then fine. So kind of in conclusion, this isn't a fine-con issue. You have to go away and think whether this is good enough for your class, or it's good for your class, or it's not. So it's up to you to decide whether this is good, but here's a couple of issues that I've come across. I think that's it. Very quickly, I don't know if it's 5 minutes, but that's it. My screen.
Thank you, James.
Thanks.
So now we're going to move on to Alvaro. So we'll start sharing our screen. And again, please be patient with us. Should it work for you?
So, should just.
Yeah, so they can see you and they can hear you.
Okay. Hello, everyone. Thank you very much for assisting. Thank you very much for inviting me. I'm just a student, and I'm going to share my experience with Lean as a student at the University of Exeter. So, first of all, short introduction. I currently study mathematics with economics. I'm on my second year, and I come from Colombia. So it's been a very immersive thing to, first of all, try to understand English and also Lean. So it's a good progression, I think. So I'll be quickly. My other slides aren't technical. So Lean has helped me a lot with understanding mostly logic. In my first year, my teacher was Ihan. And well, it was a very interesting concept that he showed during his lecture. So we already had our normal traditional lectures, and he also introduced a lot Lean to us. It facilitated the use of theorems, and it helped me comprehend what they truly represent as a proof. So I began to see proofs in a very different way than the traditional way we were taught, and it made my life as a mathematician, trying to understand proof, it made it much easier because it was a much more interactive way of looking at proofs. So it simply made it simpler for me as a student. So again, I was in Colombia by that time. COVID just limited transport, and I had my lecture 6 hours behind. So I was basically doing Link at 2 a.m., 3 a.m. So my first experience was with Crook, as James said. That's the primary way of sharing Link without any installations. And it was very confusing at first because the GUI is not very intuitive. At the beginning, Jihan had to explain lots of things and repeat it many times. Nonetheless, I began to be very interested in the concepts overall because I think it's a very powerful thing if you think about it. So our lecturer Jihan gave us lots of resources for us to check outside the actual curriculum. And well, I began to develop my knowledge during my free time. So these are my recommendations to lecturers. This is just recovered from many students that, again, shared with. We also had Jihan as a lecturer. First of all, they recommended. My first recommendation is investing more time into showing how Link works, what the idea behind Lean is, and many of the basic types that are available in Lean, like natural numbers, real numbers. Well, those different types that you can find inside all the code. Also work throughout all tactics that we generally use. So link them to the actual formal idea of proofs and how they're shown inside Lean. And invite students to also solve their normal traditional exercise sheets in Lean. I just heard, I didn't know, that is a really hard thing to actually match them. So it's interesting to know as well. And also, please give students extra material because at the end, it's not compulsory, but students will always appreciate extra material for their information. They'll learn more and they'll be more interested on what they're learning. So useful resources I had as a student, the Lean Prover GitHub that's something I found. The natural number game very popular now in this meeting. And the X-Link Discord server, which is the extra Discord server. And I found a YouTube channel, also being shared in Discord, which is the Lean Perfect Community YouTube channel. And those are great resources I've used to more or less gather my knowledge. So I don't know if they're also good for class. Thank you very much for your attention. And I don't know if you have any questions, or are we?
Thank you. We'll have the questions afterwards for everybody.
Okay.
Thank you very much, Alvaro. So Alvaro and James, you'll be patient with us. We'll get the questions towards the end of this session. So we have now Beth and Dylan. So I'll start sharing your slides and you can take it from here.
Oh, you're doing a double act.
Yeah.
We
It's about the same things.
Yeah, I thought we've had the same experience.
I mean, yeah.
Just to let you know that the camera is seeing the person who's not here.
We can just stand here so they can see us though.
Hi there. So yeah, we just basically called each other a couple of times and talked about what we found most useful for learning Lean, and what sort of we thought maybe held us back.
You stop to say that we're
yes.
both students. I'm a postgrad, I'm a one-year master's student.
Yeah, and I'm a fourth-year student at Imperial, so I'm on the integrated masters, and we both learned Lean on Kevin's formalizing maths course.
Yes.
So yeah, start off with stuff we found helpful, and one of the main ones was the exercise sheets. So we were given exercise sheets in the form of essentially, there would be a long explanation of, for example, groups and some of the group theory API, and there would essentially be a load of theorems, and instead of having proofs, they would just have sorries. So you would just have to delete this. Basically, the natural number game. It's basically like the natural number game, but it's exercise sheets. Yeah, all of maths. But in any case, those I think we both agreed were.
Sorry, the sharing options does not seem to work. So they've been saying.
They're just seeing us.
No, Alvaro's presentation. So just bear with us. We're here.
Oh, that's great. That's done.
The system takes its time. I don't know why.
But yeah, we found the exercise sheets, which is really helpful for getting a topic introduced, getting started.
It was basically just because when we actually did our projects, we had to do some of our own university stuff in Lean, and the exercise sheets gave us the ability to do, I guess, the fun part, which is the actual game part, which is the proving, without actually having to write the statements, write the proofs.
Yeah.
And for us, that's what we definitely found the hardest. So these exercise sheets were a great entryway position for that.
Yeah, I think one of the other really useful things is this, the list of tactics. So Kevin showed his course notes that linked to his course notes earlier. And the first two chapters were very sort of useful for getting started, but the one which I found that I was always turning to was just the tactics table, because I mean, maybe by the very end of it, I sort of was referring to it less, because after a while you'd kind of got a lot more used to these things, but I think that just really helped make it a lot more fluid, like the experience of, I've just got this table, I know that I want to do this thing to this hypothesis, so I rewrite something, add something, or, exact or apply. I thought that was very useful.
Yeah, and then the next thing we found useful, which was similar to what Alvaro said about the Exeter Lean Discord server, we had our own Imperial one, which definitely had some people who aren't actually at Imperial, who maybe sometimes caused a few problems. But overall, it was really good. It was the fastest possible way to get feedback. Literally, sometimes you'd ask a question and we get a response within a minute, and it really helped us to kind of understand what was going on in that level.
Yeah, I think one of the main things that would be for is you'd be writing a proof for ages and ages and ages, and eventually you just get to, I know I want to say this one thing, but I don't know how to say this one thing in Lean, and a lot of the time that's when you would eventually go, okay, I'll turn to the Discord server, and someone's always there right away to just say, oh, you do this, and then you could maybe get better explanation later. And also, one of the things we thought was really nice is that we didn't, it probably wasn't possible to go really into the details of Typhoid, because, we're also trying to just learn to actually be able to use the program, and that involves a lot of practice and just doing maths that we understand. But it was the sort of surface level intuitive sense of what is going on with it, I think was conveyed really, really well. That like, you know, you'd see a map from something to prop, which, you know, beforehand as a mathematician, you'd sort of be, I don't know what that means. But I feel like you could, yeah, got to a point where, well, I don't exactly know what a type is and what type theory properly is. I feel like I can at least interact with it to the extent where I can, you know, write lean code.
And understand the errors, definitely.
Yes, yeah, very true. And then, yeah, his stuff we thought was good that we
so the main thing was library search and hints. I think Kevin introduced us to this like in the middle of the second project, and I was like, wow, this is amazing.
Yeah.
And it really helped.
Sorry.
If we'd have been this in like project one, like week one, this would have been so much more helpful. But it was, we'd learned it eventually, but it's just stuff that like would have been like one of the first things to mention, because otherwise you'll spend ages proving something, and then you'll actually ask like Kevin about it and be like, oh, this is already in lean, like someone proved this 10 years ago, what do you mean?
Yeah.
But yeah, otherwise it was really good.
And also more generally, just like the benefit, just the way to search the Mathlib documentation and just interacting with the API. Like I think having those emphasized to us early has been very useful almost for the first project. One thing I keep bringing up to Beth is that I did not know there was a difference between have colon equals and have colon for almost the entire, I only realized this halfway through my third project. And so I spent the first two projects basically constantly wanting to, you know, like I would in a normal mathematical proof, say, oh, I want to assume this, and then I can just prove it. You know, I'd say, well, I have that this is true, and then I could justify it. That's how I'd normally argue. But if you try, you know, doing that with have colon equals, you'll just get H prop. You know, you'll just get a proposition. It won't ever ask you to prove it. It'll just say, oh yeah, you have that proposition you asked for. Here it is. It's a proposition. But it doesn't matter whether it's true or false. And I found this incredibly confusing because I kept going, I want to say, yeah, assume this, and then I'll prove it in a second. And then eventually I just sort of out of frustration, I said to you, like, is there a tactic? And you said, oh, it's have. And then I showed you my code, and you're like, oh, why have you got these equals there? So yeah, it's, I mean, more generally, just things like the subtleties like that, like, I don't, maybe that is in the notes. I don't think it is in the notes.
Big experiment. This is just poor teaching.
Yeah. We can write code.
Yeah, this is just a 10-minute roast of Kevin.
Yeah, 10-minute roast of Kevin. No, but I mean, things like this, like I think maybe it'd be useful to go, yeah, slightly more in detail with the tactics and how you can use them and distinguishing cases like these. Yeah.
And then the next thing was like the emphasizing the importance of communication, because I don't know if this is a thing elsewhere, because this was a coursework we were doing. There's kind of something you have in the back of your mind, just like, oh, we shouldn't really talk to each other about it. We shouldn't ask this many questions. And it kind of took until like the second project to realize it's completely fine for me to be like, Dylan, what is going on?
Yeah.
How do I do this? And to like message Kevin. And Kevin, to be fair, was really great with this. To be like, you can ask this questions, but I think it actually took him like 5 weeks of saying, ask me questions,
yeah.
to ask him questions.
I mean, we're saying this, I mean, you might well have, you probably were emphasizing this kind of from the start, but I guess it just really was a really key issue, I think, for both of us, was just that, you know, at a certain point, you're going to get so frustrated getting stuck that you just need people to help unstick you, and you're not going to get that without communication at all. Also, structures and sort of generally things that aren't in tactic mode was another thing that I think we both, I certainly would like to understand a bit better. I feel like I got to the end of this and I'm you know.
Yeah, I also taught them poorly.
Yeah, just having you working in tactic mode, but when it comes to interacting with, like, if I want to define something, you know, I probably know roughly how to do my at-class structure, so on and so forth. And maybe by the end of it, I had used an instance once and kind of knew what an instance was. But in general, just everything outside of tactic mode, if I didn't have a goal with a bunch of hypotheses in the bottom right, I felt like I was completely lost just in that. And that wasn't necessary for the course, but I feel like it would have just made reading bits of the documentation easier, maybe, or just maybe also just given us more options.
Yeah.
And these are, yeah.
So definitely I am completely the first person, things to consider. This is for people who want to teach the course, and I guess anyone who's kind of learning it. I am like the most computer lit person ever. I think I terrified Kevin so much with how little I knew about computers and anything. So I didn't know what Discord was. I had no idea what was going on with GitHub, but I had no idea what was going on for like the first 3 weeks of this course. And I think there was a certain almost expected knowledge of computing, of like computers compared to like computing. And I think that's just something to be aware of like, yes, there are going to be some people who know exactly what Discord is, like Dylan, and there are going to be some people who actually know how to access all of the information a lot easier than other people.
Yeah, I mean, I spend a lot of time online, but it's not like I've ever interacted with a command line. I think that the quote earlier from James was mathematicians don't automatically know how to input things in the command line. Like even just starting new projects, I remember somewhere in the notes when it says, and then you're going to type lean project in here or something, or you're going to, at some point it didn't specify whether to put it in a command line or to put it in something else, and I spent a while just going, am I meant to type this in my command line, or am I going to like delete everything on my computer by typing the wrong thing in here? I didn't really, but then, we got through that, but yeah, there's a big sort of barrier to entry in that if you don't have someone like Kevin there explaining exactly what to do, it can be a bit scary. And then, in general, also certain parts of the like API and the documentation, especially the bits where the code gets a bit shorter, like the meta code, I think we were referring to it and stuff. It would be nicer to have, I guess, just more tooltips everywhere, more hints everywhere, just like at least rudimentary explanations of what some of the more obscure bits of the math library are.
Or just be like aware if like people are going to do like a topic in an area, maybe just check the API. Because I remember Kevin in our lectures would click on like the API and be like, oh, are there no comments for this? I'll add it later. And like he'd go back and add it later, which meant that when we went to go look at this API and try and understand what was going on, let's say graph theory, Kevin would have actually gone and made comments so we could understand, because it's so much harder than it should be to look at the API and actually go, oh, this is what this is saying, and those comments really do help.
Yeah, it's just the theorems about the objects you're doing. Like, people that aren't familiar.
We thought an inter-university Discord server would be a really nice idea, just because it'd be cool to see what students at other universities are learning, and I can't see any real downside. The way that the Discord server was primarily used for our course was asking for quick questions, and I feel like the more people who are proficient in Lean you have in one server, the quicker you can get feedback to your questions.
Especially because if we're doing it at maybe like a higher level, even if we don't know Lean as well, if we know the maths better to a higher level, because we're both fourth years, let's say we help the extra second years, we can help them not just with the Lean, but with the maths as well, because presumably we will have done those courses before. Yeah. And I think that it would be good to have like
something that we can learn off of, the PhD students that you're going to get.
Yeah, and it can be like a nice little chain of helping.
Yeah. One of the big things was when still on things like Discord servers and communication, you can often, you'll be stuck on, I want to say this, and then you'll go in the Discord and you go, I want to say this, and somebody will say, oh, just type this, and they'll give you like one line of code that will just do exactly what you wanted, and then you say, oh, that worked, thank you. And you're kind of left there going, well, I don't have this problem anymore, but now I've just got this line of code that I never would have feasibly typed in my life, and I don't really know what half the things in it mean. And normally what would happen is Kevin would come back around afterwards and he'd come back in the meta chat and he would like give a more thorough explanation of exactly what it was they just told you to type into your computer. But I think it's effectively just a danger that people are very happy to, and like sometimes you wouldn't get responses if you'd, instead of saying, oh, fix this for me, give me a line of code that solves this, you said, could somebody explain the difference between this tag, like apply an exact or something to me, or using something else? You're much less likely to get an answer than if you just tell somebody to solve a problem for you, in a certain sense. If you ask for something if you ask in a chat to have something explained to you in a way that you're going to understand, people sort of don't really know what to say, whereas people, if you say, I can't make this work, people love just going, oh, I'll make it work, and then I'll tell you how. So I basically just want to emphasize that there needs to be a focus on actually not just getting quick solutions, but also.
I think at one point I was doing like an analysis thing, and at one point I reached the point that my statement just didn't make sense, because Lean thought that like 1 divided by 0 or something was 0, and there was like obviously an error in my analysis, and I put it into the Discord server, and someone went, oh no, that's completely fine, there's no syntax error there. And I think Kevin had to come along like 3 hours later and be like, no, this is definitely a problem. This doesn't make sense. You can't have 1 divided by 0 is 0. And I think it was just kind of like making sure that like Kevin did, making sure going through what everyone said and to make sure we haven't just taken the advice of someone random.
So bigger server, but also more explanations. Just asking for everything. And that's really all we had to say.